So in this video, we are going to learn how to use the Pythagorean theorem.
Okay, the formula for the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs that form the right angle and c is the hypotenuse, which is also the longest side. This formula only works with right triangles.
So now, we are going to learn how to use the formula to prove that a triangle is indeed a right triangle. So, we are going to use the numbers 3, 4, and 5 for our example. So you plug the numbers into the formula, where 3 is A, 4 is B, and 5 is 25. 5 is C, I'm sorry. So, you get 3 squared equals 9, 4 squared equals 16, and 5 squared equals 25. And you add 9 plus 16, you do get 25, which equals to 25, so this triangle is a right triangle.
Let's try another one with the numbers 5, 10, and 15. You plug the numbers into the formula and you get 5 squared plus 10 squared equals 15 squared. So you solve out, and 5 squared is 25, 10 squared is 100, and 15 squared is 225. You add 125 and you get 125, which does not equal 225, which means that this statement is false, which means that this triangle is not a right triangle.
So now, let's learn how to use the formula to find a missing segment of a right triangle.
You can use a calculator, so then, because the numbers will not always work out, so you can use a calculator.
So, for our example, we'll use the numbers 3, 4, and C. So you plug the numbers into the formula, where 3 is A, B is 4, and C remains C because we don't know and it's a variable. So 3 squared equals 9 and 4 squared equals 16, which is equal to C squared. So when you add 9 plus 16, you get 25 equals C squared. Now, to get rid of the exponents, you find the square root of the numbers. So the square root of 25 is 5. So C equals 5. Now remember that you can always plug the numbers back into the formula to check that your answer is correct and the triangle is really a right triangle. And just a side note, that conventionally, when the answer is not a whole number, you usually surround the answer to the nearest tenth.
Okay, let's try another one with the numbers A, 15, and 17. So you plug the numbers into the formula and you get a squared plus 15 squared equals 17 squared. You solve out and you get a squared plus 225 equals 289. You subtract 225 from each side and you get a squared equals 64. To get rid of the square, you do square root, and the square root of 64 is 8, so we get a equals 8, and you can always plug it back into the formula.
So now, let's do some problems together.
A and B can be interchanged because they are both the legs.
So, let's use the numbers 13, 11, and 25, and we are going to prove whether the triangle is a right triangle or not. So we plug the numbers into the formula, where 13 is A, 11 is B, and 25 is C. So now pause the video, solve and get the answer, and then replay the video to make sure if you got the right answer or not. So, when you solve out, you get 169 plus 121 equals 625. So when you add 169 plus 121, you get 290, which is not equal to 625. So this triangle is not a right triangle.
Let's try another one, and you can use a calculator. We have the numbers 7, 8, and 35, and again, a and b can be interchanged. So we have a squared plus 7 squared equals 35 squared. Pause the video here and solve it on your own, then resume it to find the answer. Okay, so when we solve, we get a squared plus 49 equals 1,225. You have to subtract 49 from each side, and you get a squared equals 1,176. You find the square root, and you get a equals 34.3 when you round to the nearest 10.
So now, you're going to do some problems on your own to make sure that you got the concept of using the Pythagorean theorem. So for the first problem, you're going to find the missing side length with the numbers 2, 4, and c. For the second problem, you're going to prove that whether the triangle is a right triangle or not with the numbers 8, 6, and 10. And for the third problem, you are going to find the missing side length and use the numbers 14, 18, and b. And remember, you can always round your answer to the nearest tenth and use a calculator to find the answers.
After you're done solving these on your own, you can resume the video and find the answers. Now, let's try a word problem. Again, you can always go to the end to get your answer after you solve.
So, let's imagine that a girl named Alexa is trying to send to her best friend a monitor for a desktop computer. So, the features on the website say that the computer is 27 inches long, which you know is diagonally long. So,
she measured it, and she got that the computer was 12 inches tall. Now, the shipping company said that it can only be a certain size, so she has to find the width. What is the width of Alexa's computer?
Solve the answer on your own. Remember, you can use the calculator and round your answer to the nearest tenth if necessary, and then resume the video again to find if you found the right answer or not.
Okay, so here are the answers to the first three problems. In number 1, where you have to find C, the answer is 4.5. Again, you have to round to the nearest tenth. For number 2, where you had to prove, the answer was yes. And for number 3, where you had to find the missing side length B, the answer was 11.3. You can find the answer to the word problem on the next slide.
Now, if you were confused which question was which number, the first question was the one where you found the missing side length of C. The second one was proving the triangle, if the triangle was a right triangle
with
or
the
not.
Numbers 8, 10, and 6.
And for the third problem, you had to find the missing side length of B.
Okay, so the answer to the word problem is this. The width of Alexa's monitor is 24.2 inches. If you got all of these answers right, then congratulations. You have successfully completed the Pythagorean Theorem. If not,
then go over the video again or try to find a book which teaches you the Pythagorean Theorem, and if that doesn't work, you can always ask your teacher.
And there's a short assessment to be completed which your teacher will hand out to you tomorrow.